Welcome back. This begins our exploration of the topic of logic, and this is one of my favorite topics for many reasons. It helps us specify the rules of mathematical reasoning. It is the basis of all automated reasoning, and so to that end, it's used in applications to the design of computer systems, programming languages, artificial intelligence, the specification of systems. It's extremely important in so many areas of computer science. To that end, let's start exploring it. So what is logic? Logic is just the study of truth and falsity. It looks at theorem and proof. And we're breaking our modules down into logic and then into proof and a look at how this applies to theorems. But it moves in that direction. And mostly, it's the basis of all valid reasoning. It's going to teach us how we can approach and understand how to construct correct mathematical arguments. So how do we create a valid argument, and how do we know if we're in front of one? So there's two different types of logic, and logic can be broken down into propositional logic and predicate logic, and we'll get to see both. But we're going to start off with propositional logic. And propositional logic is going to look at the truth and the falsity of statements, how we construct logical statements using basic logical operators such as and or, and then just a good look at how to reason. So if we have valid arguments in front of us, how do we know where they would lead us? After that, we'll move to predicate logic in a different topic set, and that's going to look at a framework of how to write logical statements. So the goal of this logic module is going to be that we're able to define a formal and, most importantly, an unambiguous language in order to express our reasoning. And unambiguous means that no matter who looks at that, it will be taken in the same way. There's only one way to read that. I started off with this, but why logic? Logic is truly the foundation of computer science. It's used in so many areas. It's used in natural language processing, circuit design, programming languages, artificial intelligence systems, logical reasoning, optimizing compilers, and so many different other areas. These are just a few. So as I mentioned, propositional logic is that exploration of truth or falsity. So the first thing we're going to do is set forth with understanding some basic words that we'll make use of. The first one is proposition. A proposition is a statement that is either true or false. And in programming, this looks like a Boolean expression or a Boolean formula. It's an expression that, when resolved, is either takes the value true or false. And we use variables, propositional variables, and we typically start with the letter P. So it would be P, Q, R, S, and so on to represent those. So for a particular proposition P, each has its own truth value. And the truth value of P is its truth or falsity. So the truth value of P could be true or it could be false. Propositions are declarative statements. These are statements that are declaring a fact. They typically end in a period. So examples of these might include a fact that 17 is a prime number. So I'm declaring that to be the case. Justin Trudeau was the Prime Minister of Canada in 2019. Or 5 plus 12 equals 17. These are propositional statements, and they either take a value of true or false. Here are some examples that are not propositions. So, do you like this course? Well, you either do or you don't. But in and of itself, that's not a declaration of a fact. That's a question. Study daily. Well, I think you ought to. It is also not a declarative statement. It's a command. And so as such, It doesn't take the value true or false. It's really important that they can be evaluated as true or false. But here's an interesting point. Here are some other propositional statements. Angela Siegel was the Prime Minister of Canada in 2017. Note that that's still a proposition because it takes on a value of true or false. In fact, in this case, it takes on the value of false. These statements need not be true. They must be facts that can be evaluated and have a truth value that's either true or false, but they needn't be true. So 1 + 1 = 3 is another example of a proposition. Every even integer greater than 2 can be written as the sum of two primes. Here's a really interesting one that we'll come back to later. This is interesting because this is something called Goldbach's conjecture. And in fact, we don't know if this is true or false. And that's what makes this one special. It's still a proposition, and it absolutely is either true or false. However, we don't know. Another question you might ask yourself is, does language matter? Here's some examples. The sky is blue. Well, we can agree that that's either true or false. And if we change the language to French, le ciel est bleu, then it's either a true or false fact. But language doesn't change that. However, if my sentence, my declarative statement is the word duck starts with a D, if I change that to Spanish, we get the sentence, la palabra pato comienza con una D. And so here's a problem, because if I translate the word duck, it becomes pato, which starts with a P. And so it takes a different truth value than the sentence in English. So does language matter? The answer is sometimes, and it depends how the sentence is translated.